Hi, my name is Keziah Belisle. I'm 16 years old and a senior in high school. The topic I chose for my Breakthrough Junior Challenge is going to be the basics of functions. So, first things first, question, what is a function? Well, if we consult a dictionary, it'll just tell us that it's a relationship between two variables. That didn't really help us much. As you should remember, every equation is a relationship. So what's so special about a function? Well, it's actually one simple rule that will tell you if it's a function or an equation. And that is 1y for every x. Now remember that letters or variables are interchangeable. So you can do a, b, c, but for this lesson we'll be doing y and x. So 1y for every x. And I'm going to explain this rule using a metaphor because every time I try to think about this rule forwards and backwards and my brain melts just a little bit. So I have a simple metaphor that makes it a lot easier. Y is my glass of cold milk, and x is fresh out of the oven chocolate chip cookies. Okay. Boom. I need 1 glass of milk for every x. But I can have 1 cookie or 2 cookies or 3 cookies, but I only ever need 1 glass of milk. So that explains a function. What's not a function, an equation, could be explained with you have 5 glasses of milk and 1 cookie to share between them. It's not a function because you don't have 1 y. Y is really just the answer. You want only one answer for your possible question, and so you don't want a couple different answers that can be explained, like some of the quadratic equations we've done before in the past. You can have 2 different answers. That's not what a function is. You only want 1 y for every x. 1 answer for every question. Okay, get that down. So let's look at some functions. This one's really simple. It's y is equal to x squared. Okay, anytime you put x in, you only get 1 answer. If x is 2, you only get 4. If x is 4, you only get 16. 1 answer. And also remember that the variables are interchangeable. A is equal to b squared. Same question. I'm going to use x and y's today for the sake, it's just simple to use because when you later use functions, you'll learn how to graph with them. And so it'll be easier to remember on the y and x axes. So, I explained that this is a function, but what's not a function? It's very simple. This question, x squared plus y squared is equal to 10. Now I could just tell you it's not a function, but let's work out the problem and see. So, what's the answer to x squared plus y squared equals 10 if x is 3? Okay. 3 squared plus y squared is equal to 10. 9 plus y squared is equal to 10. Is 3 squared is 9. Y squared, distributing the 9, subtracting from each side. Y squared is equal to 10 minus 9. Y squared is equal to 1. We're going to put the square root over both sides. And y is equal to the positive or negative square root of 1. Remember, the square root of 1 is 1, so y is equal to positive or negative 1. That means you have 2 y's, 2 different answers for your question. So it's not a function, it's an equation. Get that out of the way. Hope that's easy to understand. 1 answer for every question. Right. So next thing we want to learn is functional notation. This is how we write functions. Okay. If we go back to our original equation, y is equal to x squared. X is the independent variable. Independent. Because you're going to solve for it first. You can put anything in for x. Doesn't matter. It's independent. y is the dependent variable, you solve for y second, and it's always dependent on x. Okay, see, now they kind of work together, self-explanatory a little bit. So now you know that. So for functional notation to work, you're going to write out the independent variable, and you're going to put it in parentheses, and on the left side of it, you're going to write the dependent variable. So in this function that we're talking about, y is equal to x squared. Y is equal to x squared. X is the independent variable, so you can put it in equation. You can put it in parentheses, and then you can put it. So it should look like this. X is in parentheses, y is not. Now, do not get this confused with your algebra days. When we put parentheses in the function, this does not mean timesing. That no longer applies here. This now reads y of x. That's what the parentheses are saying, and it's an abbreviated version of y is the function of x. Y in the function of x. So that's what that means. In parentheses there. But let's say you have two different functions and they both are using the variables y and x. Okay, and if you're going to use functional notation, it will be a little bit confusing if they're both y of x. So a little trick mathematicians use is you're going to label a function. And you can use any letters, but most mathematicians use f and g. So you have function f and function g. So now it's f of x. F in the function of x. You're just placing it in the place of the dependent variable. It's very simple. F of x. The last thing we want to explain today is the domain and range of a function. Right. As always, we're going to go back to the original function. The domain of a function is anything the independent variable can be. Okay? So in this particular problem, it's x squared. X squared could be a positive number. It can be a negative number, because you can square negative numbers. It can be 0, and the answer is just going to be 0. So the domain here is all all real numbers and 0. Y is the dependent variable, and that's what the range is. Everything the dependent variable can be. So, in this problem, y is x squared. So if x is a negative number, y is positive. Because once you square a number, it can't be negative. So that's something to pay attention to. If x is 0, y is 0. If x is positive, y is positive. So the only thing we ruled out about the range is negative numbers. So the range will now read the range of y is all positive real numbers and 0. Okay. A different question though. How about y is equal to 3 over x? Okay, this is different. I can do 3 over 1 for x. I'm finding the domain here. Do 3 over negative 1. I mean, it's negative. You make the whole fraction negative. I can do any number here, but the only number I can't do is 0. Because you can't put 0 on the denominator of a fraction. It's not allowed by math. So the domain here is all real numbers except 0. And let's look at the range for y. If x is positive, y is going to be positive. If x is negative, y is going to be negative. If y can be 0, I mean the outcome of a fraction can be 0, but only if the numerator is 0. And the numerator is 3. So that rules 0 out for the range as well. So the range is all real numbers except 0. Okay. And that's it for functions.